Welcome to this tutorial. In this tutorial, I'm solving question number 1 of paper 21 of October-November exam series of 2021. The question says figure 1.1 shows a wooden bench of weight 2000 Newton. So there is a bench given in the question and the weight of the bench is 2000 Newton. Now the bench has some dimensions given to us also, and the length of the bench is given to be 2.2 meters here, and the width of the bench is given to be 0.48 meters. Each of the two supports that has an area of 0.040 meters square in contact with the ground. Calculate the pressure on the ground due to bench. So this bench is in contact with the ground with the help of these two supports. One is here and the other one is here, and we have to calculate the pressure exerted by the bench on the ground. So we know that the formula of pressure is normal force per unit area. The force would be equal to the weight of the bench, which is 2000 Newton, and the area would be twice the area of one support. So I'm multiplying the area, the given area 0.040 with 2. So it becomes 1000 divided by 0.040, and the answer we get is 25,000 pascals. So this is the answer for this part, 25,000 pascals. Next part says the center of mass of the bench is 1.1 meter from the left hand end of the bench and 0.24 meters from the front. Okay, so now we are given with the center of mass. So the question says it is at a point which is equal to 1.1 meter from the left hand end, and similarly it is 0.24 meters from the front. So this becomes the mid of the table where the center of mass of the table lies. Suggest one reason why the center of mass is in this position. So the reason we can state is the bench is symmetrical left to right and front to back. So center of mass is in the middle. So as we have seen in the figure, the bench is symmetrical, so it would be half at a half distance or in the middle from the lengthwise and the widthwise of the bench. The next part says there is a force exerted vertically downwards from the point P as shown in the figure 1.1. Calculate the maximum force that can be exerted vertically downwards at P without the bench rotating about the point Q shown in the figure. We are exerting a force on this point P, and this line becomes the pivot. This line would become the pivot for us. So due to this force, the bench is supposed to rotate in the anti-clockwise direction. Similarly, the center of mass at the center of mass of the bench, the weight of the bench would act downward. So we would experience a clockwise moment because of this force. The bench has to remain in equilibrium, so both these moments are going to be equal. So from the line of rotation or the point of rotation, the distance of force P is 0.25 meters. So the distance would be this much from this point to the line of action of force of weight of the bench, and this could be calculated when we subtract 0.25 from 1.1 So it would give us 0.85 meters. So we are going to use these values. The value of weight is 2000 Newton and its distance is 0.85 meters. Then there is a force of P creating an anticlockwise moment at a distance of 0.25 from the pivot. So first I'm writing the principle of moments here, that clockwise moment should be equal to anti-clockwise moment. So for clockwise moment, we have a force of weight acting at a distance of 0.85. For anti-clockwise moment, we have a force of P acting at a distance of 0.25. So P is going to be equal to 2000 multiplied by 0.85 divided by 0.25. So it will give us an answer of 6800 newtons, and this would be the final answer of this part. So the question ends here with this answer.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.